Assalamu alaikum. My name is Engineer Hamza Amin. I'm a student of Seacoast University and doing my master in geotechnical engineering. So today I will represent my master work, which title is Evaluation of Shear Strength Parameters of sand touches by using direct shear and triaxial shear apparatus supervised by Dr. Danish Jahan. As we know that tires use is increasing significantly every year and day by day, and the disposal of the tire has become a major issue. It's both legal and illegal because affecting our environment by causing some diseases which danger disease and can transmit, and also it's fire holding the capability, which have been devastating our environment and polluting our air. So, because of that effects on the environment, in early 90s, civil engineers and researchers thought that why not we should get benefit of the properties of tires which are good in engineering experts. So from 90s officially it was started to use or to get benefit from the tire chips in different ways. So our and today the purpose of our research is also that to why not we should use it as a backfill material for our uh, in our construction industries or in retaining structures. So the problems statement or the problem we have been facing because that every time backfill material is heavily backfill material are used in a or construction industries or in a retaining structure, which in terms increasing the cost of the retaining walls and other embankments, abutments. So, and the more critical reason is that we are using our natural resources for these kind of work. So in future we may face depletion of our natural resources. So the problem, and why not we, and instead of effective our environment, our climate by cutting mountains for sand and other materials, or why not we should use already artificial material we have, and it's also affecting our environment. So the problem or the need of the research start from this problem. And the objective of our work is to evaluate the shear parameters of sand touches mixture by using direct shear and triaxial shear apparatus methodology, and also to compare and analyze both of the apparatuses results, and also to use our proportion of mixture as a backfill material and retaining structure critically. And to achieve our objective and goal, this methodology was used in this process, and to the values which we observe from this methodology are explained in the next slide. So the specific gravity of the soil was observed as 2.67, and soil was classified by Uniform Soil Classification System as a poorly graded because it was collected from a locally construction site, especially where I was working as a site engineer. So I thought it would be more good to use the backfill material or the soil or the sand which we use in our construction industry. So I took it from that place where I was as a site engineer. So the dry density of the sand was observed from 1.75 grams centimeter cube for, which was calculated from modified Proctor test, and the attributes of the direct shear was the dia was 52 mm, Normally we use square shape. I have seen a mostly square shape, but as in our institute or lab, we got new apparatuses, which was such a circular, direct shares was in circular, and triaxial was according to the setting, but also was in smaller size. So it was the triaxial shear apparatus. Aspect ratio was 2:1. So 72 mm was his height, and dia was 36 mm. And we for specimens we use plain sand 20%, 30%, and 40% types by weight of sand. As our apparatuses were small and as per requirements and standards, we use very small and tiny tile chips, which size was always almost equal to 0.05 mm, and and it was less than the highest size was 0.5 mm. So these were the characteristic or the details of which type of material are we using in our work. Three kind of loading or normal systems were applied in direct shear apparatus: 150 kPa, 100 kPa, and 150 kPa, and all specimens. So total three tests were performed on each sample. So I will explain just at 150 kPa the comparative analysis of all specimen. At the initial, all the behavior of the all the specimen were the same, up to almost zero point 0.5 or 0.045 mm of deformation. But then after that, it changes, and we can observe that with the increase of tire chips, the maximum shear stress increases. uh, but up to 30% shows maximum shear stress, highest maximum shear stress as compared to 20% and plain sand, but at 40% it decreases. It because of the segregation phenomena. As our dia box of shear dia box was small in shape, and we know that sand tire chips are lighter in weight, but they have uh, more volume as compared to sand particles. So the particles segregate at the bottom. So because of that, segregation phenomena happens with at higher adding of higher percent of tire chips, the shear stress maximum shear stress is decreases. Here is the comparative graph of the normal stress versus maximum shear stresses. So you can observe that sand have a lower value as compared to touches, but at up to 30% it has more, then it decreases at 40%. Also in triaxial shear test, three kind of loading were applied: 50 kPa, 100 kPa, and 150 kPa, but as a confining pressure. So after applying confining pressure and going into shearing stress, and the weight stresses were applied, so we can see that at the initially at up to 3 mm, the behavior of the specimen of all the specimen were almost the same, but after that increase of deformation, it changes, and the increase of the vertices. Here we can observe that peak value for sand has been observed, and after getting into peak value, its deviated stress value decreases with increase of deformation. While 20% of tire chips by weight of sand is not showing, or any percent of tire chips are not showing us any peak value, and it's taking stress value with increase of deformation is getting is linear. So with increase of deformation, it's also taking more deviated stress. It's because of that the sand-to-sand interaction is more as compared to sand to tire and tire to tire. So you can observe that at optimum value 20% were observed, was observed, while with getting into more percentages of tire chips at 40%, it's uh, almost decreases. Because and also the because of this property of the tire chips of taking larger strain at higher deviator stress has able us to use it in a seismology or seismic area. So because of its ductility and deformability behavior, we can use it in many geotechnical and earthquake engineering aspects. So because and so showing us a really good behavior as compared to sand. So here is the comparative shear strength parameters of both the apparatus cohesion and internal angular friction. While in triaxial, we have calculated the effective parameters, shear strength parameters, while in rise here we have just the limitation of total. So where we can observe that with the increase of tire chips in direct shear, the angle and cohesion both increase up to 30 percent of tire chips, while in sand the cohesive nature increases with the increase of tire chips, but angle of internal friction slightly decreases. So these were the parameters of 10. So here it is the graphical representation of shear strength parameters of both the apparatuses. So it was also described in the previous slide, and but here you can see that 30% of tire chips is giving us the same cohesion value for both the apparatuses, and the angle of internal friction is also explained. The goal of our experimental work was not just to observe numerical value, but also to represent what will happen at the end, at the failure stage. So we can see that by adding of tire chips in sand, that the specimen fell at bulging, while without sand it fell at 45 at shear plane, and angle at 45 angle they were plus theta by 2. And in direct shear, whether it was sand or sand tight chips, the failure plane was horizontal, in which the lower case was static and the upper case share at the horizontal. So no, because of that, the drawback of using direct shear apparatus is also that it doesn't shows us what will happen at the end, what shape we will get. So it will not help us to uh, work more extensive. While in triaxial shear, it was clearly observed that a specimen will flail at different shapes, different kind of materials are used. So our goal was also achieved in this work to show the picture what a failure. So now we are getting into conclusion. I won't take longer time here because I have already explained almost my conclusion in the graphs. So I will make it short. Here, like the airing of tire chips have affect the mechanical or the shear properties of the even the deformation properties of the sand drastically and very ineffective way. And we can see that with the increase of confining pressure also the values deviated stress value increase, same as for direct shear. With the increase of normal stresses, the maximum shear stresses value were increased, and no peak stress were observed in direct shear apparatus for all the specimen, while in triaxial only for sand peak deviator stress were observed. And the other thing that shows brittleness and more better behavior, while Santa chips show a ductile behavior. So because of you can see that the behavior of its failure, you can observe it also from the behavior of its failure. So these points were already discussed in previous slides about the normal stresses and maximum stresses and which person perform well and the failure depends of both the apprentices were explained in previous slide. The goal of this work was to compare and observe the results visually and numerically, and we almost succeeded in getting our goal. And the second goal will be achieved when it is performed practically, because it will help us to build really economical retaining structure because of the lightweight of the tire chips and more good engineering properties such as hydraulically and seismic wise, as we have seen that with passage of time the seismic effect is getting more crucial, and we are even like we have to be prepare ourselves not just in a building wise, also in the retaining structure, because it can cause major losses if we didn't what we call didn't put our observation or concentration on these kind of thing as seismic wise too. So it inshallah hopefully our goal is to use it critically too and make our work more valuable, so many people can get benefit from our research. So thank you for your time, and I will thank again the administration, and thank you.